Hey everyone, and welcome back. So I'm here in the back archive freezer at the National Ice Core Lab where it's minus 38 degrees C, and I have my glove off so my hand is freezing, but what you see behind me are tubes of ice cores from dozens of different ice core projects that the US Antarctic program has put on. And in some cases, some of these cores are even from other countries, Russian projects or European projects, and there are thousands and thousands of meters of cores. So each one of these tubes has a meter of ice in it from hundreds or thousands of meters down in either the Antarctic ice sheet or the Greenland ice sheet or some alpine glacier, and stored within these cores are all sorts of information, paleo information about the past. So past climate, past chemistry, past volcanic eruptions, all sorts of interesting things we can learn from these cores about the past. And so it's really fascinating. You can see there are thousands of them, and there are multiple rows. So there's row after row of ice cores, thousands and thousands of cores. And just for some fun, we've got Mr. Freeze in here as well. So as you can see, my eyebrows and my eyelashes are already starting to freeze, and my hand is starting to get frost nip. So I'm gonna go back in the warm and I'll show you what we do with some of the samples. So out here is the main processing room, and as you can hear, it's really loud because it's running all of the compressors and the air conditioning units to keep it cold in here. But this is where, when we get cores in, we run them through all of the different saws and cut all of the samples up for the different laboratories and universities. And you can see I've got some samples laid out here in these bags, some samples here, some samples here. So we're working on all sorts of different samples. Over here, we've actually pulled some cores out of tubes. So this is actually a piece of an ice core right here. As you can see, this core is pretty broken up. It's in a lot of pieces. Long story about this core. It had lots of trouble with being extra brittle. And then I'm gonna take you in the exam room here. And this is the room that I do all my work in. So up here, we've got an instrument called a microtome. And this is where we basically put ice samples and shave them down so that they're ultra thin, and we mount them on glass plates like this. This plate here has a very thin piece of ice on it, and what we can do then with the ice is we can put it on a special stage like this, and when you look at it through polarized light, you can see all of the ice crystals for this particular sample. Why do we care about the ice crystals? Well, that's a really good question. So the reason that I'm interested in looking at how the crystals are oriented, how big they are, their distribution, questions like that, is because it tells us about the history of the ice, how the ice has flowed, how it's deformed, the temperature at the site, because temperature determines how big the crystals get, how much it snows at the site, how much vertical strain is on the ice. All these questions about strain and stress and deformation and ice flow history and ice dynamics, really important questions as we try to understand where the Antarctic ice sheet is going in the future with climate change, and is it going to be stable, is it going to collapse, is it going to melt, all these really important questions. And so this is where I work. Now over on this stage here is where we take our bubble images. So this is where we can actually look at the tiny bubbles in the ice cores. All right, so what you see here is a sample put on the bubble imaging stage. And each one of these tiny dots that you see in this section of ice is a tiny bubble of air with trapped ancient atmosphere in it. And the other thing you might notice is that some of the bubbles are very elongated or skewed and kind of all orient in the same way. Basically what that's telling you is that this particular piece of ice was under a certain type of strain that basically pushed all the bubbles and squeezed them in a certain direction. The other thing you might notice is that right here, there's sort of a very clear delimiter between the different orientations of bubbles, and that's because that is a line separating two separate crystals of the ice sample, and the crystals on this side were deformed this way and the crystals on this side were deformed that way. So again, it really speaks to sort of the history of the ice, the strain and the stresses that the ice has been under. All right, so I'm in the dark booth at the ice core facility, and I've got a core here from Greenland, the GISP 2 core, from a depth of 1,841 meters. And what's really unique about this core is you can visually see all of the annual layering in the core, and you can actually count the number of years represented in this core, and that's because accumulation in the winter is more dense than the accumulation in the summer, so you can actually see dark layers, light layers, dark layers, and so forth. So let me show you. If you look at the core, you can see a dark layer, a light layer, a dark layer, a light layer, all the way down the core. Each one of those couplets represents 1 year. So in this entire core, there's about 50 years of history, climate history, atmospheric history, chemistry history, dust history, you name it, biological history from small microbes or whatever. This entire core covers over 50 years, probably about 20,000 years ago or something like that. I don't have the depth age scale in front of me, but somewhere probably 15 to 20,000 years ago. So absolutely fascinating, and this is why I love this field so much. All right, well, I hope you enjoyed this little tour of the National Science Foundation's Ice Core facility here in Lakewood, Colorado, where we store all of the U.S. program's Ice Core archives, and where I spend most of my time when I'm not out riding my motorcycle or running on trails. Back here in this minus 36 degrees C freezer, or up in the exam room there, looking at samples of ancient ice, trying to learn what I can about Earth's history in the polar regions. So I hope you enjoyed. Take care, be safe, and I'll see you guys in the next video. See ya.